Hi everyone, my name is Juan Pablo. Welcome back to a new YouTube video. And in this opportunity, we will talk about one interesting feature that is quite common whenever we are migrating from LDP to segment routing. Well, I wouldn't say quite common, but it's very useful to know because as we saw in the previous video, right, the migration from LDP to segment routing is just with one command. So we just need the srprefer command to be enabled, and then we will switch all the forwarding plane from LDP to segment routing, labeling. Now, in some networks, the migration is not that easy, and it needs some phases and transition. So it needs some stages, and even sometimes the LDP part of the network has to coexist and need to work out together with the segment routing part of the network. Okay, so in that coexistences is whenever we need this feature that is called segment routing mapping server. Okay. Now, before going into the details about what is or how to configure segment routing mapping server, we need to understand why we need this feature. Okay, so let's imagine we have this network here. I will split just this network in two sides just to make it better understandable. So let's have this side that is LDP base. Okay, the left side of the network, and the right side of the network is segment routing base. Okay. We are running here ISIS in process 1 and area 1. Okay, all the devices are running in area 1. Now, whenever we have one part of purely segment routing and the other part purely LDP, of course we need to make them to coexist, because in one side of the network it can be a router, a P device that have a C connected. The other P device is in the segment routing area, should has also probably a customer that is under a BRF, and of course both of them needs to communicate to each other, and they need to know what is the label of the loopback of each other, right? P1 needs to know what is the label of P2, and P2 need to know what is the label to reach the loopback of P1. Okay, now this is to make the service to work. Okay, so in this case, whenever we have LDP in one side and we have segment routing in the other side, the coexistence and the propagation of this label is not that quite easy, especially for the segment routing part, right? So let's examine it. How it works LDP. LDP works basically assign a label, okay, to every prefix in the RIP and FIP, right? So for example, if we have LDP enabled in this device, in this device, in this device, obviously they will establish LDP sessions, so they will exchange the labels of each other. Now, we are in the common IGP domain, so meaning that P1 by IP base knows the loopback of P2. P1 has in the RIP and FIP the loopback of P2 because they are in the same routing domain, right? The same provider 1 and the same provider 2. So provider 1, provider 2, because they speak LDP in this side of the network, they assign a label to the loopback 0 of PE2, right? Of PE2. And they propagate this label to PE1, okay? Both of them, provider 1 and provider 2, they know the loopback of PE2 by the RIP and FIP. They speak LDP. LDP assign a label to all the prefix in the RIP and FIP. So it means that they, provider 1 and provider 2, assign a label for the loopback of P2, and they propagate the label to PE1. So for example, if the label in LDP that provider 1 and provider 2 assign to the loopback 0 of P2 is 24,007, then they propagate to P1, and P1 knows what is the label to reach the loopback of PE2, right? It's 24,007. So from this side of the network, whenever P1 receives a request from the customer, for example, C1 wants to reach C2, then P1 knows what is the label to reach the loopback 0 of P2, right? So P1 doesn't have any problems in the forwarding of the label. So we can state here that whenever we have LDP in one side and segment routing in the other side, from the LDP side, we don't have problems to reach the loopback of the other PEs in the segment routing domain, because the way that LDP works. Now, what happened with the segment routing domain? Segment routing, as you saw in the previous video, it works based on the prefix seat, right? So we configure the prefix seat under the loopback 0 of the devices, meaning that P2 has a prefix seat that is 16,002, correct? But we don't know what is the prefix seat of P1 because P1 is not in the segment routing domain. P1 is in the LDP domain. So no one tells P2, hey, the prefix seat of P1 is 16,001, for example, right? No one does this advertisement to P2. And the way that segment routing works is, specifically for the loopback of the Ps, is by assigning the prefix seat. We need to do it manually, right? And specify either if it will be index or it will be absolute value, as we saw in the previous video. So the naturality or the nature that segment routing works doesn't allow P2 to know what is the loopback, P2, to know what is the loopback, the label to reach the loopback of PE1. So we have a problem here, because whenever P2 will receive a traffic from the customer 2 that wants to reach customer 1, P2 will not know the label to reach the loopback 0 of P1. And if I don't know the underlay label, I cannot put the overlay on top. The overlay will get lost in the middle of the network, meaning the service label, because they don't speak that label in the forwarding plane. So it will be a black hole here, and the traffic will not work. So what we need in this case, we need a device that will tell P2, hey, this is the prefix seat or the loopback or the label, sorry, for a loopback of P1. Take it and use it for the forwarding of the traffic, right? So we need some device that will tell us and will be able to communicate that to P2. And that device is the mapping server, okay? And for that, we need to configure the mapping server. We need to define in the network which will be the device, the route reflector, the provider, whatever device that they speak. It can speak LDP or it can be also in segment routing domain, but any device that we choose in the network can be a mapping server, okay? And we need to configure that device and tell, hey, for this specific IP, I want to assign, for example, for the loopback 1111/32, I want to assign an index value of 1. So with this, I configure this in the mapping server, and I said for the loopback 1111, the index value that it will have in the segment routing domain will be 1. And you know, in our case, we are using index. So index is, the label is calculated based on the segment routing global block plus the index value that we configure. So if we configure index value of 1, then the label will be, for the 1111, will be 16,000 plus 1, so 16,001, okay? But we need to configure that device, and we need to propagate that prefix seat label into the whole segment routing domain. So we need two tasks here: configuring the mapping and propagate that mapping across all the devices that speak segment routing. And exactly is the two things that we need in the network, in the configuration itself, okay? So let's open it up, the configuration here. And in our case, well, I will just explain a bit more the scenario. We have the same network as we saw in the previous videos. P1 and P2, they have a services that are C1 and C2. They are under a BRF, right? They have a VPN before session with the route reflector, and of course they propagate the routes to the route reflector, they propagate back, and they send it back to the customers as well. In C1 we have the 100, 100, 100, 100, and in C2 we have the 200, 200, 200, 200, okay? So I will do an extended ping from C1 to C2. The ping will fail because in my current scenario I have this split domain that I talked to you. We have LDP base here, I have segment routing base here, and I don't have configured the mapping server yet. I will configure this device, provider 1, as a mapping server, and we will see the two tasks that we were talking about, okay? For now, I will just show you what is that P1 can see the loopback plus the label to reach P2 because of the concept that we explained. And P2, we will see that cannot see the loopback, or sorry, the label to reach the loopback of P1. And of course, the ping, we will try it out now, and it will not work because P2 doesn't know the label to reach the loopback of P1. okay? The loopback of P1 is 1111/32, and the loopback of P2 is 2222/32. So let's do it. First, let's run the ping. Let's go to C1, and let's do a ping 200, 200, 200, 200, source loopback 0, repeat 100, or 10,000, okay? The ping doesn't work because if we go to P1, show Ceph 1111, show Ceph 2222, I am looking into what is the label to reach out to P2, is 24,007. So here we have a label to reach out the loopback of P2. Now if we go to P2, it's called Cisco. We go to P2, this is provider 2, and here we have P2, this is P2. Okay, show Ceph 1111, then here we don't have a label. There is no label. We need to configure again the mapping server and propagate that label over the segment routing domain. We will configure provider 1 as a mapping server. The way of configuring is segment routing, mapping server, prefix seed map, because we need to do the mapping of the prefix seed for the loopbacks, address family, IPv4, we want to configure in IPv4, 1111/32, and the index value that we want to start, okay? In this case, I will type 1 and enter. That's all the configuration that we need. We need to tell the mapping server the loopback 1111 will have the index 1 in the segment routing domain. That's the task number 1. The task number 2 is to propagate that over the ISIS domain, where the routers that speak segment routing, remember that segment routing is an extension of an ISIS, and it consumes many TLBs. One of them is that tells all the routers that they support segment routing. I think it's a 238 TLB, and over that is that also this propagation of the prefix seed is being made, okay? But we need to tell that to propagate the prefix seed mapping in the mapping server to all the networks. So the command is segment routing prefix seed map advertise local, okay? The receive is already configured by default in all the segment routing domains, so we don't need to configure. We just need to advertise from the mapping server over the ISIS domain. So these are the two tasks that we defined and we need to have. Configure again the mapping from the loopback to the prefix seed and propagate over our ISIS domain. Commit. And now if we go to P2 and check, we give some time, the label should appear right away. So now we see the label 16,001, and if we go over the ping, now it works, okay? So that's it, the mapping server. Remember, define a device that will be able to propagate all the mapping to the segment routing domain. There are more design constraints on that, because if you can have the mapping server as a control plane, but if you have separate IGP domains, you need to have the mapping server in the middle. That's where we will focus in the next video. Put a mapping server whenever we have in this scenario here. For example, we have OSPF. There might be this type of scenarios. ISIS. We have devices in the middle. This talks LDP. This talks segment routing. This scenario might happen, and here the mapping server has to be in the middle as a transit, as a route reflector inline that we normally commonly call in the segment routing network or concepts, let's say. And in that case, you need to configure mapping server over here as well. There are specific things of design that we will talk about potentially in the next video. Okay, so that was for now. I hope you have enjoyed and you have learned something, and thank you very much for watching. See you in the next video. Bye.